Okay, here we're looking for the second derivative at particular points. So that means we've got to take the derivative twice. If we look at part A, I'm going to start by taking the derivative with respect to x on both sides. When I do that, on the left, I will get a 2x times a 1 plus a 2y times a dy dx. And on the right, I'll have the derivative of a constant, which is 0. So now if I want to isolate the dy dx, I need to subtract the 2x and divide by the 2y. So that will give me dy dx equals a negative 2x over a 2y. Before I take the derivative again, it will probably simplify things for me if I simplify the derivative. So I can reduce those 2's out. I'm left with a negative x over y. So now I know that the first derivative is this negative x over y. So to get the second derivative, I need to apply that operator d dx to both sides again. When I do it on the left, that will give me my second derivative of y with respect to x. And on the other side, I will need to apply the quotient rule. So the quotient rule, if you remember, is the low one times the derivative of the high. And I'm going to keep that negative up with the top. So the derivative of my high is a negative 1. So there's my low d high minus my high times the d low. Notice that d low is the derivative of the y with respect to x. So I get a dy dx. And on the bottom I'll have low squared. If I simplify this, I get a negative y plus an x times a dy dx. Well, remember that dy dx was a negative x over y. So I'm going to replace this dy dx with a negative x over y, and all of this is divided by y squared. So we could, if we wanted, plug in our point right now, but I want to show you a little algebra so that you know how to simplify this. If we look carefully, we have a negative y minus an x squared over a y, and then we're dividing by y squared. Well, dividing by y squared is the same as multiplying by a 1 over y squared. And if we get a common denominator for this term so that we can combine the fractions, we'll have a negative y squared over a y. Notice now that we get that second derivative is equal to a negative y squared minus an x squared over a y cubed. Now let's look very carefully at this. This negative y squared minus an x squared is the same as the opposite of an x squared plus a y squared. And notice in the original setup that the x squared plus the y squared was the same as 169. So I actually will get a negative 169 over a y cubed. Now this is much easier to evaluate at the point than this one here. So the question becomes, are you more comfortable simplifying when you have numbers, or are you more comfortable simplifying when you have variables? Because you can do it either way. I think it's easier to do the variables than to do the numbers because I tend to make more mistakes with these negatives and running around. So I will simply evaluate this now, and notice I only have to plug in the y. So I have a negative 169 over a 5 cubed. And I'm done. So let's do it again with B. B is an ellipse instead of a circle, but you'll notice a lot of the same properties coming into play. I want to take the derivative of an x squared plus a 4y squared on the left and the derivative of the constant 16 on the right. So move that derivative operator through. On the left, I'll get a 2x. On the right, I'll move through the addition, move through the 4, hit the power, leave the inside alone, that'll be to the 1, then I take the derivative of the y, so dy dx. On the other side, I have the derivative of a constant, which is 0. If I want to isolate dy dx, I need to subtract the 2x and divide by the 8y. So I'll end up getting dy dx equals a negative 2x over an 8y. Again, before I try to take the derivative a second time, I'm going to reduce this so I get a negative x over a 4y. So now I'm in position to take the next derivative. If I want the second derivative, I will take the derivative of dy dx, which means I will take the derivative of a negative x over a 4y. So on the left, I will have the second derivative of y with respect to x, and on the right, I'll need to do the quotient rule. I'll have low d high, the derivative, again, I'm going to keep that negative with the top. So the derivative of the top is a negative 1. Low d high minus high d low. The derivative of the low is 4 of those dy dx's. And I will divide by the low squared. Now, a mistake that people make on the low squared is sometimes they will just square the y instead of squaring the 4y. So you want to make sure that 4 gets squared as well. Now again, just like we did up here, we're going to replace the dy dx with what it equals. So here, my dy dx is a negative x over a 4y. So on top, I have a negative 4y plus a 4x times a negative x over a 4y. Now we're going to simplify the same way we did up here. This whole thing is divided by a 4y squared. Well, that's the same as multiplying by a 1 over a 4y squared. So, get a common denominator. This needs another 4y. So I'll multiply by another 4y. And if I put that all together, I end up with a second derivative. That is negative 16y squared minus a 4x squared over a 4y that has been cubed. Again, we can see this is the opposite, almost. I guess we can factor out a negative 4, and we'll be left with a 4y squared plus an x squared over a 4y cubed. Now notice that 4y squared plus an x squared, that's 16. So I have a negative 4 times a 16 over a 4y times a 4y times a 4y. The reason I wrote it that way is because I can now cancel the 4's with the 4's that are on top. So I end up with a negative 1 over a y cubed. Evaluate at the point 2 root 3. That will give me a negative 1 over a 3 root 3.